to the THREE-Lanka project, a transformative initiative aimed at advancing renewable energy education and training in Sri Lanka. As part of this initiative, we are excited to introduce our virtual learning tools, designed to support renewable energy learning. Our virtual e-learning tools offers experiences through simulations that explains the principles of sustainable energy. We have developed 20 e-learning virtual tools to improve skills of the students and knowledge in the renewable energy sector. These tools span key areas including solar and wind energy technologies, biomass systems, hydropower, hydrogen storage, waste-to-energy processes, and battery technology. Each tool offers both theoretical insights and practical, hands-on experiences for students. In designing these tools, we carefully considered multiple aspects of skill development to ensure a comprehensive learning experience. These virtual tools were developed with 3 key objectives in mind. 1. To enhance understanding of theoretical principles, particularly focusing on functional relationships. 2. To provide insights into the maintenance and installation of renewable energy systems. And 3. To teach circuit design and familiarize students with the core components of renewable energy systems. Let's take a closer look at the diverse modules included in this platform. Power generation from a geothermal plant. Explore how geothermal energy is harnessed from beneath the Earth's surface to generate sustainable power. Biomass for energy production. Understand how organic materials are converted into energy, driving renewable power through biomass systems. Energy storage systems. Learn about cutting-edge technologies for storing excess energy, ensuring a stable and reliable energy supply. Analyzing energy consumption factors in electric vehicles. Dive into the factors affecting energy consumption in electric vehicles, optimizing their performance and efficiency. Tidal current energy. Discover how the movement of ocean currents is converted into renewable energy using underwater turbines. Power generated by a wind turbine. Gain a deep understanding of how wind turbines capture wind energy and convert it into electricity. Additional modules include waste-to-energy plant operation. Learn how waste materials are transformed into usable energy in waste-to-energy facilities. How to build an offshore wind farm. Experience the step-by-step process of constructing a wind farm in the ocean to harness wind power at sea. Wind turbine installation procedure. Master the key stages of installing a wind turbine, from foundation construction to assembly and alignment. How a solar farm is constructed. Get hands-on experience with the design and installation of large-scale solar farms for efficient energy capture. Identification of components of a wind turbine. Familiarize yourself with the essential components of a wind turbine and their roles in energy production. Hydrogen storage system. Understand how hydrogen is stored and used as a renewable energy source, crucial for future energy systems. Further modules explore advanced principles and technologies. Lambert cosine law. Apply this scientific law to understand how the angle of sunlight impacts the efficiency of solar panels. Basic solar power circuit. Learn how to design and understand solar power circuits, connecting solar panels, batteries, and controllers. Bioethanol production. Discover how organic materials are converted into bioethanol, renewable fuel that plays a critical role in energy transition. Small hydropower plant. Explore how small-scale hydropower plants harness the energy of flowing water to generate electricity. The virtual tools are designed in a manner to deliver learning outcome in different areas. First, the student will provide basic theoretical content. Students will understand the theory content provided earlier and then use simulation tool to change parameters and understand how output is vary according to the parameters. Every virtual tool will end by assessing the student's understanding. This practical focuses on understanding the loss of effective irradiance caused by the angle at which sunlight strikes a photovoltaic (PV) device. When a PV device is not positioned perpendicularly to the sun, there is a loss of irradiance due to geometry and reflection. By applying the Lambert cosine law, students will learn to calculate the reduction in irradiance caused by non-normal incidents. This practical provides critical insight into how positioning affects the efficiency of PV systems, equipping students with the theoretical knowledge and skills needed to optimize solar panel orientation for maximum energy capture. This virtual training is designed to help students understand and apply the key formulas related to the power generated by a wind turbine. Through this practical, students will learn how to calculate the blade's sweep area, consider the effects of air density, and accurately determine the overall power output of a wind turbine. By engaging with these core concepts, students will gain a deeper understanding of how wind turbines convert kinetic energy into electrical energy and how each variable contributes to the efficiency and performance of wind energy systems. This virtual tool provides an overview of the fundamental steps involved in the installation of a wind turbine. Students will learn the key stages of the process, from site preparation and foundation construction to the assembly of turbine components, such as the tower, nacelle, and rotor blades. The students have to align videos demonstrating wind turbine installation procedure by the end of this module. Students will have a clear understanding of the installation process, preparing them to engage with real-world wind turbine setups. This module is designed to help students identify and understand the key components of a typical wind turbine. Participants will explore the function of each component, including the rotor blades, nacelle, gearbox, generator, and tower, and how they work together to convert wind energy into electrical power. By the end of this practical, students will have a comprehensive understanding of the role each part plays in the overall system, enabling efficient wind energy generation and power output optimization.